Hello, in this video we are going to learn how to create a weeping angel, basically someone who moves towards you when you're not looking. And you could obviously change it to the opposite way too, where it only moves towards you when you're looking at it, so it's up to you. So first of all, I'll show how to create for single player, and then we will change that blueprint to work in multiplayer, because it's easier to explain the techniques and technical stuff in the single player, and then in the multiplayer it goes like way too, it's like going back and forth, which is why I like to explain in the single player. So right now this is single player. You could see if I play, this is how it looks. I'm looking at it, so again ignore the line traces, but you could see I'm looking at it, it does not move at all. If I look side, you could see it just popped here, you could see, and it also shows on the left, top left, that the player is not looking and then he's moving. And you could see that if I get blocked by some walls, then also it basically starts moving. And you want to add this line trace, which is like blocking. You have to check for blocking of walls. If you don't use this line traces to block this, what would happen is, let's say if you have multiple rooms and multiple walls in between and then you're really far, it would basically think that you're looking at it even though there's like multiple walls. So before we start, I'll quickly give you an overview of the blueprint. So on event begin play, I've basically created a timer so that every 0.1 second this event runs, which is check if the player is looking. So the first thing we check is if our player is looking at the enemy or weeping angel. The way we do it is by getting the forward vector of the player, so basically where he is looking at which direction he is looking at, and then we get the location. When we do, let's say, from our location minus the player's location, we basically get the direction from our player's location to the enemy, which is ourselves around in this case. And then when you normalize this, we get a direction. Basically it's very basic vector math that you could search on. And then forward vector is already in 0 to 1 because it basically gives us direction, so both of these are direction. And then we basically check a dot product of it. Dot product basically gives, let's say if they are facing the same direction, the dot product would give us 1. If they are facing, let's say they're facing 90 degree to each other, then it will give us 0. If they are facing completely opposite, then it's going to give us -1. So we can basically say that if it's 0.5 or more, then we are kind of looking at the enemy. So if we are looking at the enemy, or let's do first this. So if we are not looking at the enemy, so if it is lower than this, we basically are just not looking at the enemy. We do false, and then we basically tell that the enemy is not observable, which is there's some extra variable in here, so don't worry, but the enemy is not observable. And then we basically send it to move, which is like code around here, which I'll explain what it does. But we basically tell that we can basically just start moving towards the player. But if our player is looking at the enemy, which is true, then we do one extra check, which is checking if there's an obstacle between our player and enemy. Because if there is, like, let's say 5 walls in between, then we don't want it to stop, right? It still should move towards the player. Because there's a wall, it doesn't mean that the player can see it. So we do one extra check, and the check is very basic. We do a line trace from player to enemy, or we could do enemy to player, it doesn't really matter, by line trace. Then we get a result around here, which is hit or not. So what we could do is, if there's a wall in between, if there's a true, then we basically say that it is not observable. So what we can say is, if this is true, which is there's a wall in between, we basically turn this to false by going in here, and we can say it is not observed, so that we are not getting observed because there's a wall in between. If there is no wall in between, which is this one, which this would turn to false, it will basically say that we are observed. Because there's no wall in between, we are getting observed. So this not is basically just a way to reverse it. You could also just remove this and turn this to, let's say, is blocked and all, but then you will need to do some changes. And then we basically just send this value to the move. That is, if we are getting observed, start moving toward player. If not, then we just stop. So this move, which is this move and this move, it does one thing which is around here. It basically check is our player looking at us. If the player is looking at us, we basically just stop the movement instantly. Like instantly we just stop the movement and we set the variable is moving to be false. This is moving variable is just a way to kind of not use much processing power by just stopping the code. So if we just go in here and then set this to be false, we can just go in here, we can say that player is not looking, then we can basically start the moving code. So it's moving. Are we already moving? If we are already moving, then we can just say we are already moving, so don't do anything. But if we are not already moving, then we can run this code called AI move to, and then we can set to AI move to. So every 0.1 second, it can check that if we are already moving, then we don't need to do anything. Because if you don't add this, then the code would run till here completely, and this code is a bit expensive. But this one is like not much, so we can just stop it. So let's get started to make a single player one. So let's start making the first one. Okay, so I'm just going to create a new folder and then just call it tutorial or something. So I'm actually going to create everything differently so that I can start from scratch. So I'm going to create game mode pace, but we will actually switch this to game mode when we are doing multiplayer version. Okay, so this one is for multiplayer, it has more features, but this one is good enough for the single player. So let's just use the game mode pace and call it like TUT Weeping Angel. I'll just name it short forms right now for tutorial. Game mode, okay, game mode pace or something. Then I'll just place it on here. Now I'm just going to use my previous player controller. It has nothing. If you check in here, it just has a mapping context that is added around here, and I've also set is local controller. This is only for multiplayer, like this is local controller, because in server, when you create, let's say, a listen server, what happens is that the server has copy of every single player controller. So if there are 5 players, then server would have copies of 5 player controllers. So you want to only make this mapping context for the local controller and not for the rest of it. Clients only have 1 copy of themselves, which is okay, but if you are server, then you would have all of them. So you don't want this to run 5 times in a server basically. So if you're doing multiplayer, you could directly connect it like this and add your mapping context or however you want. If you are using like basic third person, you don't even need to do this. Okay, so I'll just use this on my player controller class and I'll create a new character, which I'll just copy actually from my character around here. Okay, so I'll just name it TUT. It's nothing, it's just basic third person character. And if I double click on it, you would see nothing's added. It's all the basic stuff that comes in. The only thing that I added was a mesh, because it's a first person first person character, and in first person character they don't provide this mesh. So I just went in here, selected my skeletal mesh around it. It's usually empty for first person template, but I added this, and then I also added ABP manage C, and then I selected this, selected owner, no C. So what this basically means is that you would not see it, but other players would see it. This is not important for single player, but for multiplayer it's good, because other players would be able to see the full model, but you would only be able to see like only just this, I guess this where is it, like first person mesh. Okay, and this one you could see it's set to only owner C, but you don't need to worry about it for single player. I'll create a blueprint and I'll use character, or you could use character or pawn. But the reason why we use character or pawn, because we want to use nav mesh, which I'll explain in a little soon. But that's basically allows us to use the AI controller to move towards the player. So we'll go BP underscore TUT underscore weeping angel enemy or something. Okay, let's just double click it, and then you could simply just select a mesh around here. I'll do escape many, I think -90, and then let's rotate it to so that it looks at the front like this. Okay, so we got a mani, and then we can basically give it the default anim mani. Now this one is for single player, so let's quickly make it for the single player. It's very easy to do, especially for single player. So first of all, we will do a test to see whether uh, we are looking at the general direction of the enemy, which is this weeping angel. I actually added the code in here instead of adding it in my character, because maybe we don't want to use the enemy in every single level, so the code would be in here, and then if we are not loading this, then the code would basically just not run because it's not here. But if we add it in, let's say, my player or something, then the code would always be there. I don't know what's the best way, but I think this is like the best way to do it, because it just does not load it, and maybe if you kill it, then you could basically destroy it or something. So first of all, we will do is we will get self reference, and we will be using dot product. Now dot product is like very basic stuff. So actually we will get the forward vector of the player. So let's do get player character, and this one would basically give us 0th player. And what this basically means is that if there are, let's say, 2 players, and if you change this to 1, it would turn to, let's say, first player. It's not a good way to do it, but because we are using this as a single player, there will always be 1 player, so this one is always going to give you the same player. Okay, not good for multiplayer, this one, so stay tuned for the multiplayer version. We need to get its forward vector. Okay, so let's search for forward vector, and then we will get the capsule components forward vector. Okay, and not the mesh. And let me explain to you why. So if you check the player, which is our player, this one, if you, let's say, went and did forward vector for mesh, it's actually going to be this red arrow. So this red is forward, this is right, this is up. So the red would actually be not the forward. It's simply because that's how the mesh is made. Okay, if I, let's say, rotate it to 0, well, not that way. If I rotate it to 0, you could say this is the forward vector. The red would always be forward vector, and it is not perfect for this mesh. I don't know why they have made it this way, but the capsule component, which is like the root of this, it will always be this red color one. Okay, which is why we use the forward vector to get of the capsule component. So now we need to get the direction from one to another, so that we get a vector, and we will have to get from player to the enemy, which is our weeping angel. So we have to do this. We cannot do opposite direction because of this option. Okay, I'll explain why, but let's just bear with me. So we have to get a direction, we can simply just get the vector of this and get the vector of this, and then basically if this is a, vector is nothing but the location value. Okay, it's not much complicated, so don't worry. If this is b, if you do, let's say, b minus a, we get the vector, and then we have to normalize it basically. Then we get the direction of this one from a to b. Okay, if you do a minus b and then normalize it, we get from this one b to a, like this. So if you ever want to find a direction of let's say one player to another, or anything like anything from one direction to another, which direction it is facing from this player, you could just simply use this normalization. So let's just do it. First of all, we need to get, so you could see we have to get our enemy. That's why I like to draw, because it makes it easy to understand. So we can just do self reference, or you could just do this one too also, get actor location, and it will basically give you the world location of this one by default. Or you could just do this one too, which is get world location and then get the capsule components. Both would work. Okay, so this is R, which is our weeping angel. From our weeping angel, we will minus the player, which is going to be this one, but instead of forward vector, we will get its world location, like this. So if we minus from our enemy to this guy, we actually can get like this, which is this one. Okay, so minus, and then if we normalize this, we can actually get the direction like this one. Normalize is nothing but it converts the values that you get around here between 0 to 1. I don't know the actual method to do it, but I do know that it basically turns to 0 to 1, and the forward vector is always going to be 0 to 1. So there are three values because it's a vector, and all three of them would be in 0 to 1, and that basically gives a direction. Just look into vectors, like vector stuff. Okay, it's very basic. So now what we have is a direction from our player to the enemy, and then we also know which direction our player is facing. So is it facing this way, or this way, or this way, or this way, like this. Now the thing about dot product is, if these two directions are same, the dot product would be 1. If this do like this forward vector, okay, if this and this are perpendicular, it will give us 0, and if this and this is like this opposite, it will give us -1. So if our player is looking completely opposite to the enemy, you could see we are basically going to get -1. If our player is looking exactly at the player, both of these parallel, so we are going to get 1. If our player is looking 90°, then it's going to get 0. And then if this is, let's say, 90°, like this, if this is 0, then we will slow, and this is like 1, like this one is 1, then we get like 0 0.1, 0 0.2, 0 0.3. This is not a good way to show, but basically it will go from 0 0.1 to 5, 0.6, 0.7, 0.8, 0.9, and then 1. So what we can say is, let's first do dot product. Okay, so dot product of this. Now for temporary purposes, let's run this on event tick, and what we can say is, if this is greater than, let's say, 0.7, let's try 0.7 and then do branch. Let's do this one. If you press B like this, it opens a branch. If this is true, if our dot product is greater than 2, we can basically do a print string and say looking at enemy, and then I can do not looking at enemy, and this one I'll turn to red so that it's easy to see. And then another thing is, you need to add this nav mesh. For temporary purposes, you don't need it, but when we add the AI move to tool, we will need this. The way to add this is like very simple. You just search for nav mesh bounce volume, you like drag this in like this, accidentally added 2, and then basically just scale it to compass whatever it is. And if you press P, you would see it basically shows like where our character can basically move, where our AI character can basically move, and these are basically where it cannot move. And then you could basically add like more walls and stuff, okay, like this. And then this is basically where it cannot move. If you press P again, you can hide it. Again, we don't need it yet, but again it's going to be like way too early to check. So if you check select it, oops, let me make this. I forgot to add my default character, player character, to around your default pawn. If you go in here and then set it around here, it would be better than setting it around here, okay? That way wherever you use this game mode, it will automatically use this data. So this is my player, and it says looking at enemy. But if I, let's say, you could see that even though it's in my vision, it's saying not looking at enemy. But if I look at the enemy perfectly, it's showing looking at enemy. And then this is, let's say, let's see how much, and around here it's like 0.7 value. I found out for my testing that 0.5 works better for me at least. And then you could see that I'm looking at enemy, looking at enemy, looking at enemy, not looking at enemy. Okay, so this is basically what works best for me. Even though you're looking up, it's still paying because it's the same direction. That's like one thing I haven't really fixed, like looking up and down. Okay, at least for temporary purposes, but it's basically based on in general direction. Okay, so even if you're looking, let's say, straight, but if you're facing that direction, it still stops. So again, I haven't really fixed that one, but for now let's just do it this way. Okay, I actually just found out this issue right now as I was looking up and down, and you could see the issue that because there's a block in middle, it still says I'm looking at enemy. That's why we also do a line trace. But before we do that, how about we actually start moving it first, okay, based on just this stuff. So I removed the event tag and I'll create a custom event, and then I could check is that move towards player question mark or something, and then I'll just place it around here. And the thing is, event tag works at every single frame, which is why we will use something called set timer by function name. These two are same, but if you use function name, it just allows you to place it like wherever you want, and then just copy the name and paste this around here. If you create functions also, you could just paste this name. But if you use, let's say, set timer by event, then you need to actually connect it like this, which is kind of annoying. So I just like to use this one. I'll do 0.1 seconds. So every 0.1 seconds, it should loop. We will run this code, okay? And then you could reduce it, you could make it 0.3, 0.5, and that way this code would only run every 0.5, 0.3 seconds. And if you do like event tag, it's really bad because it will run like every 16 milliseconds or something. This is also like way too fast, but for temporary purposes we'll do 0.1, and then you could basically just make it slower, faster. And if you want, you could also promote this to a timer. I'm not going to use this stuff, but again, like move towards player timer or something. And maybe if you want to like stop this looping, maybe for some reason if it's going way too far, then you could basically take this and then say clear timer and invalidate. So basically it stops looping this. Okay, I'm not going to do this for this video because again it's good for a bigger world when you make it. But we always simply have done right now is checked if our player is looking at that direction or not. How about we just test if it's already working or not. And you could see right now it's not loading the print string as fast as previous one because it's running at 0.1 seconds, which is 100 milliseconds. I just have this open on site to check it, okay? So just don't get confused if I accidentally just spam you with this big stuff. It's very basic, so don't worry. So let's create another event right now, and this one would basically do is move it towards the, so let's do custom event, and then let's move it towards the player. Okay, I should have named this move towards player, and then this one I should have named like check if player, check if looking or something. Okay, just name it something better. So it's now, I just change the name and then change here too because it makes more sense around here. I'll add a boolean and then I can just say player looking. You could name it anything. So if it's looking, we will do something else. So if I hold this and press B, it will create branch. If the player is looking, we actually would get the character movement like this, and then we will do stop movement. Okay, we haven't added the movement yet, but it's stop movement immediately. So let's say if the player is moving towards a let's say our enemy is moving towards a player, then suddenly it should stop. Like as soon as someone looks at it, it should stop, or as soon as your player looks at the enemy, it should stop, which is why we are doing stop movement immediately. If you don't do this, then it will not stop instantly. Second thing is we need to move it right now. Okay, So there is something called AI move too, and there's obviously, you know, state tree that you could use, behavior tree that you could use. Obviously could make it like much more complex instead of just doing in blueprint, but for this tutorial, the main thing that you need to learn is uh, if the player is looking at it and if there is a wall between, and then rest of the stuff you could basically just do it in the state tree, behavior tree, or just do it in the blueprint like this, because it's not much complex stuff in here. And then we could just do like this on false, where it's like player is not looking, we want to move, which is going to be self, we want to move self, and we want to move it towards the player actor, player character, like this. And then you could change the accept in radians and all, radius. So let's try this. You could say it's not moving at all. Let's see why. Because we never ran this code was never running. So when we are not looking at the player, we need to move towards player like this, and then we can basically just tell that player is not looking. And then if I stop, you could see it went there, but it just doesn't stop, you could see. And the reason for that is we need to go in here, go up, and then tell it that the player is looking like this. If it's true, the player is looking. So as soon as the player is looking, we basically do this stop movement immediately. If you don't do that, then this code is still running, this code is still running, but we want to stop it immediately as soon as this one changes to player is looking. Okay, so you could see that the player is moving towards me, and it also automatically blocks the walls and all because we are using nav mesh. Very creepy. But we have to now create another thing, which is if there is any obstacle or wall between us. But before that, I'm also going to create another stuff, which is moving. So is our player already moving or not? Because what's actually happening is when we are not looking, again this one, if when we are not looking, this code is running every single frame. So it tries to do this code which is false, and then it tries to update this every single frame. So instead of doing this, if our player is already moving, we don't want to run this code again and again. It's already moving towards our player character. Okay, so we can basically just take this get moving, create a branch, and then say that if we are already moving, don't do anything, but if we are not moving, then you could basically run this. Okay, so we could also create a print string to make sure it works. Already moving, and then I'm just going to turn this to yellow. But now we need to actually set this variable. By default it's going to be false, so by default it's not moving. But as soon as where should I add this? Let's see. In here, in the move towards player, when we stop the movement immediately, we have to set that, we have to tell that we are not moving. Okay, because we stopped the movement. And as soon as we are moving, we have to set this as moving like this. So we have to tell that we are actually moving towards player. So as soon as we get the information that is our player looking at our enemy or not, if he's looking at the enemy, we basically stop the movement and tell that we are actually not moving. Hey, I'm not moving. And then next time it goes around here, it checks this, and it's like, okay, I'm not moving, then start moving because the player is not looking at me. And then we have to tell that, okay, I'm now moving. And then if it keeps repeating from this path, then it will basically just stop here. Okay, if this is true, it will basically just stop here instead of running this code again and again and again and again. Okay, it must stay save memory. So you could see looking at enemy, not looking at enemy, and already moving. So again, basically the code is getting stopped. The code is getting stopped around here instead of running this constantly. But if I look around the enemy, it's basically just stopping the movement immediately. And here you could also see this is running and then telling the player is looking at the enemy, so stop. And if I don't, then it basically just goes around here, tells, hey, I'm not looking. So you could do this stuff. I'm not looking. Let's go to the false branch, and I'm already moving. So this code only runs once if you are already, moving, or before starting the movement. Now let's add one more thing around here before we do stuff. Okay, so we already know that if our player is not looking, we can basically just move towards the player. Okay, we are not moving, we are not looking, so just move it. So we don't need to do anything around here, but we need to do something around here, that if the player is looking, we also need to check if there is an obstacle between. If the player is looking but there is an obstacle between, then we basically want the enemy to move towards the player. So let's do this. We can actually delete this much, and then let's start doing a line trace. Okay, so we'll do line trace by channel, and line trace is nothing but we just shoot a line from one location to another and check if something is hitting or not, if that line was hit by something or not. So for the start location, it doesn't matter from if you go from what you call like the enemy to the player or player to the enemy for this one. So let's say self reference, and we can actually connect this one by saying get world location or something, again with capsule component, and then do start. But what I'm going to do instead is I'm going to go into my viewport, then I'm just going to add a scene component, which is kind of like an empty, so nothing's there, and I could just call it like line trace start or something, and then basically just move it outside of my capsule. So the reason why I'm doing this is simply because if you check my Whipping Angel, we are going to trace in a channel called visibility. So you could actually create new trace channels too, which I would highly recommend when you're making this, because you don't want to use the default visibility and camera for, I guess, everything, especially for this enemy and like enemy and like your specific enemy type of character like this. Just go to like project settings and then create your own line trace, but for temporary purposes I'm just going to make it this way only. And the reason why I'm doing this line trace start is because if you check this capsule component, and let's go to collision, it is set to ignore this one, so it's not going to collide with the visibility channel. So it's okay if you do it from the player, but you could see our mesh actually, okay, our mesh is also set to not collide, so this would have no issue. But still, I think it's good to create a new line trace component so that the line trace does not hit ourself. It's not going to hit it even if you do it other way, because by default you could set to ignore the visibility channel, and this one is also set to ignore the visibility channel. But I'm just going to create a line trace from here just to show that this is how you could do too. I can get the line trace and I can do get world location, and then I can just do start from here. Okay, get player character, and then do get world location capsule component, and then set this to the end. So basically we will create a line from our character to our player. Okay, and for the debug I'll set for duration. So you could say this is how you could change the color and all, but this is just for debugging. Okay, for duration and all. So if I play now, you could see we are actually having a line from the like this dude to me. It's probably towards my feet. Okay, I don't know where the line trace is going till. Let's see, let's quickly just go here. Let me look at from the further. Okay, so the line trace is actually going towards my chest, which is okay. But in case it is not going towards your chest, what you could do is you could basically add let's say something like 50 or something, and then do end trace in case your line trace is going towards your feet. Okay, again, doesn't really matter, I think, but still, your choice. Now, based on this, you could actually get like a lot more stuff for line traces. This is usually used for FPS gun shooting and all, or even for interaction stuff when you want to create like a scalable interaction which works automatically. I actually have a video on it called hard reference versus soft reference or something, or even with line traces and box collision. But we can basically just use this return value. Okay, so I'm just going to create another variable and I'm going to call it is observed, or you could even name it like is visible, is the enemy visible, or something. Is observed is basically we can see it. Okay, so this one, this line trace, if I show you guys again, if I go behind a block, you could see it turns to what you call like green, and you could see there's a spots around here which basically say that it is hit. You could see this red spots or like darker square spots wherever there's a hit. It basically is saying that there's a hit. Okay, so this one would basically give us whether there was a hit or not every single time. So if this is true, it will give us, if it hits something, then it will give us true. If it does not hit something, it gives us false. So if we check our is observed and let's do set is observed, by default I'm going to set it to be false. But if we connected this one, it's not going to make sense, because if it's getting hit, then how is it observed? Like, does it make sense to you guys? If there's a hit, it means there's a wall between us and enemy. It also means that it's not observed. So if this is true, this should not be true. So we just type not bool and it will basically just do opposite of it and give it. So if there's an hit, it will basically say that it is not observed. So because there's a wall in between, it's not been observed, the enemy is not been observed. But if there is not a hit, so if this give false, basically saying that there's no wall in between, then it will turn to true, and then it's basically be like, hey, I am observable. You could also change this to is blocked, and then basically just not use this, just use whatever makes sense to you, but this is what makes sense to me. Okay, and then we can basically just run this code again, which is move towards player, like move towards player like this, and then we can simply just add it around here like this. Okay, so is observed, if this comes true, then the player is being visible, and if it is false, then player is not been visible. Let's try this. I'm looking at it, I'm not looking, but if I go behind this, it starts moving towards me. You could see. But if I look away, now remember, if I go outside my nav mesh, it will basically just not run. I think I can press P. Okay, there. But if I go in, even if I go to this corner, it will find a way. And if I stay behind, you could see the line traces kind of show its location. So all we simply did was we first checked if we are looking at the player's direction. If we are looking at the player's direction, we have two options, right? True or false. If we are not looking at the player direction, basically just start moving towards player. But if we are looking at the player's direction, check if there is an obstacle between us or not, like this much. If there is an obstacle, then we basically just move it towards the player because it's not visible because there's an obstacle. But if there is no, then we basically just do the opposite one. This is the whole code. It's very basic.